So we are done with problem 4. Now we will move to equilibrium in 3D. Okay, so the concept is the same as in 2D. The idea is to apply the equilibrium relation into three directions, x, y, and z. So we always start from the vectorial relation, and then we decompose it into components. So I have here the vectorial relation is sum of forces equal to 0. It will give me three relations, one in x, one in y, one in z. So I can solve up to three unknowns in a 3D equilibrium problem. Okay. Now, let us do a small example in 3D. A 90 Newton load is suspended from the hook. The load is supported by two cables and a spring of stiffness 500 Newton per meter. Find the force in the cables and the stretch of the spring for equilibrium. So here, since I want to solve for in a 3D equilibrium problem, I should first determine what are my unknowns. So I have first point A is subjected to 4 forces, and one of them is known, which is the vertical one, equal to 90 Newton. Okay? So I know that this downward force is equal to 90, but all other forces are unknown. So I have three unknowns: the force in AB, the force in cable C, and the force in cable D. But at least I know that my cables are in tension, so I know the sense of forces. They are directed from the point towards the cable because the cable is always in tension. So these are FC and FD. And since they said that my spring is stretched and I want to calculate the stretch of my spring, then since A is stretching the spring, so this will be the action of A on the spring. By action-reaction, the force of the spring on A will be opposite. Okay, this is why FB is towards the spring to right. So now I have the representation of my forces. Concerning the sense, I know it because they gave me information. So for force in D, what I know is the angle of this force with y-axis. So I know it. And it's clear that this force is in a plane xy. So it will not have a component along Z. While for cable AC, it is in plane xz, so it will not have a component along y. Okay, so the first step here is to write the components of forces. So I have that for FB is only along y. Okay, so I can write that FB vector is equal just to FBJ. Okay, so it will only have y component. Now concerning force FC vector is equal to, I have two components, one along I, one along K. To determine these components, I simply do projections. So I will use here, you see here these dimensions, 4, 3, and 5. You remember, if they gave us these dimensions, we are able to find this angle here. So I will draw it for you like here. I will do the projection. So if I have the projection, this is, let's say 3, this is, it's not to scale, okay? It's not to scale here. So this is 3, this is 4, and this is 5, okay? So if you want to project on x-axis, it's clear that, look, your x projection is negative because it is in the backward direction, okay? So my projection on x is negative, and I am doing cosine of, to project on x, I do cosine of this angle. Cosine of this angle is what? Is 4 over 5, okay? So I can say that FC vector is minus 4 over 5, which is 0.8 along I, okay? While the second component will be along Z. So if I project along Z, I am multiplying by sine of this angle, which will be 3 over 5, which is 0.6. So plus 0.6. And of course, I multiply. This is, if you want, the unit vector. So I multiply it by FC. Okay. So I multiply this term by FC magnitude, which is unknown. So I can say from this equation that FCX is minus 0.8 FC, while FCK, here, sorry, it is K, not J. Okay, it's K vector. So I will write it here again. I write here again. FC along X is equal to minus 0.8 FC magnitude, and FC along Z is equal to plus 0.6 FC. Okay. Now, I move to the second force, the force in cable AD. For the force in cable AD, I just know the angle. So since the angle of with Y is 30, so when I project on Y, I do what? I do FD cosine 30. And since the projection is negative, as you can see here, so I can write that FD along Y is equal to minus FD cosine 30, okay? And FD along X is equal to plus FD sine 30, and no component along Z. So you can write any force as a vector, or you can write it as components. It's up to you. Now, for the two other forces, it's much easier. This force is along minus K, so I can just say that it is minus 90K. So it only have a Z component, while FB is only along Y, so it will only have a J component, as we mentioned previously. And now we are ready to replace in the three equations. Sum of X equals 0, sum of Y equals 0, and sum of FZ equals to 0. Okay, so if I apply now the three equilibrium relations here, you have along X, you have the component of cable D and the component of C. We have seen that along X we have FD sine 30 minus 4 over 5 FC. This is our first equation by doing sum of X component equal to 0. And the 90 force and FB do not have X components, so they will not figure out in sum of X equals 0. Now, sum of Y equals 0. We have the component of FD along Y, which is minus FD cosine 30. We don't have a component for FC along Y, and we don't have a component for the 90 Newton along Y. We only have, in addition to FD, we have FB plus FB equals to 0. So this is the second equation. Now, the third relation along Z, we have just the component of FC and the 90 Newton force. So it's plus 3 over 5 FC minus 90 equals to 0. This is a system of three equations with three unknowns, but you can solve it easily. No need for a calculator, because if we start with the third equation, you get FC. Then you replace FC in the first equation to get FD. And once you have FD, you plug it here, you get the value of FD. So it's a simple system. We can get the three unknowns. And since they asked for the stretching of the spring, we know that the stretching of a spring is given by the stiffness times delta S of the spring. So what we should do, we should just write that the force we found is equal to the stiffness times the stretching, and we can get the value of the stretching. Okay, any question on this problem?
Doctor?
Yes.
I just wanted to ask, how did we get FC along Z component?
Yes, sure. This is FC. Okay, look at your figure here. FC is in which plane? This is FC. Okay.
ZY.
Yes, if you follow, no, ZX. If you follow the
ZX,
dashed
yes.
lines, okay, you have here a parallel to X, so it has a component along X, and it has a parallel to Z, so it has a component along Z. For you to see it better, I can draw for you the projection of plane ZX. So this is Z axis, okay? This is x-axis. And the force, let's do it like this. I will put it here to have a place to put it. So this is z, okay? And this is x. And how is your force direction? Like this, okay? So this is, if I draw the 2D presentation of plane zx, so this is z, this is x, okay? And they gave us these dimensions to be able to find the angle. So you have 3, 4, and 5. Okay, so also not to scale, okay? To have it on scale, you should do it more inclined to this line. So 3, 4, 5, okay? Look, if I give you these dimensions, 3, 4, 5, you can determine what? For this angle here, if we call it theta, okay? If I ask you what is cosine of theta, if this is theta.
It's 4/5.
Exactly. So cosine of theta, cosine of this angle is 4/5. And sine of this angle is 3/5. Okay? When you want to find the component along z, you need to multiply by sine or cosine of this angle. Look, this angle here, theta, is equal to this one here. If I tell you this angle is theta, when you want to project on z, you need to find this length here, this one. First, it's a positive projection because you have, if you project, you get an upward vector, okay? And how you find its length? It's equal to FC sine this angle,
Sine.
okay? So what is sine this angle? It's 3/5. This is why
Okay,
FC is 3/5 times FT, okay?
So we look at the plane it's in, and then we draw this diagram
Yes.
to know if
Yeah,
it's sine or
if you
cosine.
don't see it from the 3D figure, just do the projection. If you try to see it from here, this angle here is equal to theta, okay? And sine of theta, you can get it from this small triangle. It's 3/5. So you can say that since FZ is opposing the angle theta, so FZ is FC sine theta.
Okay, thank you, Doc. Thank you.
You're welcome. Any other question? Okay, so see you next time. Bye bye.